Now that you've seen an example of how you can track experiments with MLflow, let's take a look at another tool you can use for experiment tracking. So we talked about DVC a little bit earlier when it came to data version control, but something else this tool is pretty good at is experiment tracking. So you might decide to use DVC over MLflow if you want a lot more customization over how you track your experiments and the way that you configure your ML ops pipeline. So with DVC, you can actually build an ML ops pipeline to handle almost all of it, even up to the deploy stage. So I think the only thing that DVC and the other iterative tools don't handle is monitoring. So if you want an open source tool or tool suite that handles all of the ML ops for you, take a look at DVC. It's a really good tool to use, at least for your data version control and your experiment tracking. So let's take a look at how you actually use DVC to track experiments. So I'm going to come over here to VS Code, and I have my source directory, and the code that we're about to walk through, you can get this same repo from the dvc.org docs site. So you can check out the whole DVC project and how it works with different ML models and how you can use some of the other tools to help automate your pipeline and integrate more really robust features as you start to mature your pipeline. So let's take a look at kind of what makes DVC kick for experiment tracking. So we'll start by taking a look at this dvc.yaml file. So this is where you can define all of the stages in your pipeline. And this might feel a little bit familiar to Circle CI. So we still have that config over here that defines our pipelines for our releases to different environments like staging and production. dvc.yaml is kind of like that, but for the MLOps stages. So what we're doing with DVC, you'll notice we have this prepare stage. So this is where we get our data. This might be where you actually pull in data from multiple sources and pull it into that central location. It could be if you execute that with a Python script normally. So you can have that stage defined. Then you see we have our featureized stage. So this featureized stage is where you come in and you, well, get your features. So you might use a tool like feature tools, like we saw earlier, to be a part of this process. And then we have our train stage, which is what we're going to spend more time looking at in just a second. And we have this evaluate phase or stage. So we take the experiment that we've just run and we evaluate it, get some metrics, generate some plots, and see how well that particular model performs. And then you'll see down here, there's a definition for plots. So this is where we define how plots are stored for DVC. So when we run our experiments, we're generating these metrics files and we want to make plots with them. So this is where we define kind of the templates that we want to use. So that's a very quick overview of how the DVC pipeline is defined. So once you have this pipeline defined, you notice we have several scripts in here. So let's take a look just quickly at some of these scripts. And this first one is prepare. So this is where we actually go and get our data from the source and we start to prepare it, get it in the right format, split it into our train and test data sets, and that's all that's happening there. Then we have our feature stage, and this is where we start to get that data. We figure out what features we want to extract, or if there's any features we want to generate, and we do that, and we have that as part of our output that will be used to train the model. So here we're using that random forest classifier again, and we have a few hyperparameters. So hopefully you remember that from last time. We're going to look at how you can automate that. So we go through this script. We have our training data, we have our hyperparameter values, and then we execute the train method and we save our model that's generated. And then finally, we have the evaluate stage. So this is where we take the model, we take our test data, and then we run our test data through the model to see how well it performs. So in this case, we're looking at things like PRC and ROC to determine how well our model classifies the data we give it. So that's a quick run through of everything that's happening in this code. So if we want to start just by going through a training experiment, remember we already have our data, it's featureized, and we've decided to use this random forest classifier. So to run an experiment with DVC, you'll use the command DVC exp run, and you'll see it's going to check for any changes in any of these stages that have been defined, which as you build more complex pipelines, that's really going to save you a lot of time, especially when you start to run things in the cloud. Because typically, when you're running an experiment in, say, a notebook, you end up having to pull the data every time, even though the data hasn't changed since the last experiment you ran. So DVC is smart enough to track if there have been any changes to a particular stage in your pipeline, and if there hasn't been a change, then it won't execute those stages. And if there has been a change, it'll execute the first changed stage and all of the stages that are dependent on it. So it's a really powerful tool, especially when you start working with large distributed ML experiments and you're working with big data and you have to manage a lot of things in the cloud. So DVC is awesome for giving you that kind of control. But we've run our experiment, so let's take a look at some of those results, or at least see how we can see results. So to do that, we run DVC exp show, and you get this nice table that has all the metrics, what the hyperparameter values were, which data sets you were using to train this model, and it gives you just the main information you need. But one cool thing with DVC that's a little bit different from the others, or MLflow in particular, is that you can automate some of your hyperparameter tuning. So if you remember, we had this grid search script. It's using DVC. So if I execute this script, it's going to generate a bunch of DVC experiments that we can run all at once. We can run them in parallel. We can distribute them across different clouds. So it gives us a lot of flexibility. We're probably not going to let it execute all of these experiments, but I just wanted to show you what it's like to use DVC to queue up a lot of experiments. So I'm gonna go ahead and stop this here. And just like grid search, it can take a little while. So let's look at that table, and you'll see we have several experiments that have been queued up, and they all have different hyperparameter values. So this is one of the other tools you have to track your experiments, and we'll take a look at how you start to evaluate your models now.